Good day, learners. Welcome back to our channels. This is Aliphatic Teaches, a channel where we teach mathematics and chemistry. If you're a new member on this channel and just coming across this channel for today, kindly subscribe and click the notification bell for my subsequent content. Now, today we're going to proceed on our circle geometry. We've looked into theorem 2, and today we're going to look into theorem 3. Theorem 3 states, the angles in the same segment of a circle are equal. Angles that lie in the same segment, they are equal. When we have a circle this way, we know that if we have a line that is dividing a circle into two different parts, the line is called a chord. So this chord is dividing this line into minor segments and the major segments. But when we say we have A and B, the distance from this A to B is called a minor arc. While the inside of this is minor segment, as we've discussed. While the inside of this larger one is called major segment, and the outside here is called the major arc. When we now have some angles on the circumference, let's say angle x1 and angle s2. This angle x1 and angle s2, they fall in the major segment, considering this called AB. So any angle that fall in the same segment, the angles are all equal. So x1 is equals to s2. That is what theorem 3 is stating. Now, we know that the center of this angle x1 is this place. The center of angle s2 is this place. And to get the angle at the center, which is this point, let's call it point y. For y is going to be 2 multiplied by what? X1, that is 2x1. Then, for this s2 as well, y will equals to 2 times s2. That is what? 2s2. This is y equals to 2s1. Y equals to 2s1. It means they are all equal. Both of them are equal. So y equals to y. Definitely 2x1 is equals to 2s2. So 2 goes in 2. x1 is equals to s2. Meaning that if we have the same angles on the circumference of the same segment, they are always equal. That is what theorem 3 states. Angles in the same segment of a circle are equal. The next theorem is theorem 4. The angle in a semicircle is a right angle. Don't forget the meaning of a right angle. That is what? 90 degrees. When we have a semicircle, when we have a circle this way, and we have a line dividing this circle into two equal parts. Any line dividing a circle into two equal parts, the line is called a diameter. Then any angle made by this line, this is the center now. Any angle made by this diameter to any part of this circumference is a right angle. Let's check this angle. So the angle here is 90 degrees. It's 90 degrees. Don't forget, the center of this angle on the circumference, let me say A, B, C. Angle C is an angle on the circumference, while the center of the circumference is this angle here. So, which means that our angle C, this angle C, to get this center, let's say center O. To get center O is going to be 2 multiplied by angle C. Do you understand it now? 2 multiplied by what? Angle C, which is what? 2 multiplied by 90. That is 180 degrees. So to now get our angle C, is going to be half of 180, which is what? 90 degrees. So which means that anytime you are given a circle and the line dividing the circle into two equal parts, that line is a diameter. That is first thing. The second one is that angle formed by that line trace the angle must be equals to 90 degrees. Let us now look at how to apply this theorem 3 and theorem 4 in our calculations. Example 1. Find the lettered angles in each of the following. Where a point O is given, it is the center of the circle. If you are a new member on this channel, please don't forget to subscribe to my channel and click the notification bell for my subsequent content. And also do share, like, and comment this class. Now, for this A, when we look at this diagram very well, if I try to put a line, introduce a line here, if I introduce a line here, you can see that this line is separating this circle into the minor segments and the major segments. So which means that angle A is in the same segment with angle 40 degree. Angle 40 degree is in this segment with angle B. That is A and B, they are in the same segment, which is what major segments. Likewise, angle C here is in this segment with 32 degree. Fine. Which means that angle A is equals to 40 degree, angle in the same segment. Likewise, angle B is also equals to angle A, which is 40 degree. Same reason. Angle C is also in the same segment with 32 degree. C equals to 32 degree. That is angle in the same segment. Same reason. Now let's consider this question B. If you look at this question B, we are told that where a point O is given, it is the center of the circle. So this point O is the center of the circle. And don't forget that any line from the center of the circle that divides the circle into two equal parts, that line is called a diameter. And the angle formed by the diameter on the circumference will be a right angle, meaning 90 degrees. Now, look at this angle O now. This point, this is the diameter. Now, let's look at the angle formed by this diameter on a circumference. Let's trace it. Okay, let's try to do it this way. Let's label A, B, C, D, E, all those points. Now, if I now trace, look at this, A to B to C, back to A. So the triangle formed by this line, this diameter, is A to B, B to C, and C back to what? E. A, which means that angle E is going to be equal to 90 degrees. Reason, angle in a semicircle. Angle in a semicircle. Now, we've gotten our E to be 90 degrees, angle in a semicircle. When we now look at this, if you look at this angle D and 115 degree, they are in the same segment. How? Let me consider this line. Consider this line BC. Line BC. You can see this small circle here. This small one here is a minor segment. This point is a minor segment. While the remaining part, they are major segments. So the angle formed by this major segment are D and this. Or consider it like this. So we have a minor segment here and a major segment. So D and 105 degree, 115 degree, they are on the same what? On the same segment. That is, angle D is equal to 115 degree. Reason, angle in the same segments. So D is equal to 115 degree. That is angle in the same segments. Example 2. Find the lettered angles in each of the following. Question A. Want to find letter K and letter L. And don't forget, since this one is center O, it is called a diameter. So this line is a diameter that divides the circle into two equal parts. If it divides the circle into two equal parts, definitely any angle made by that line on the circumference will be equals to 90 degrees, that a right angle. So let us trace this. Let's try to label this as A, B, C. So the line from this A to B is a diameter. So this C and back to A is a triangle made by it. So which means that the whole of this angle here is the angle formed by this semicircle, by this line. So the whole of this angle C is going to be equal to 90 degrees. If angle C equals to 90 degrees, and the angles that form this C, They are 53 degree and k. So 53 degree plus k is equal to 90 degree. So since this angle is equal to 90 degree, the reason of this one is angle in a semicircle. Now correct like terms, k will equal to 90 degree minus 53 degree. So k equals to, here we have 7 and where we have 3, that's 37 degree. That's value of k. When we can get the value of k, we can also get the value of L. When we have, look at this vertical line and this horizontal line, I'm going to form bus 90 here. When it's formed bus 90, total angle in this triangle, this, let me call this one M. CMA. CMA, that angle. This angle is 90 degree and this k is 37 degree. So when you sum the total angle in this triangle together, it must give us what? 180 degree. That is k plus L plus 90 degree equals 180 degree. Reason, sum of angles in a triangle. When we get that, our k is 37 degree plus L plus 90 degree equals 180 degree. 37 plus 90 degree, so we have 127 degree plus L equals 180 degree. My L equals 180 degree minus 127 degree. So L equals to, my L equals to 53 degrees. So I've gotten the value of k to be 37 degree and the value of L to be 53 degree. So every step you take in this circle geometry, you must always give reason. Why is your answer like that? That is why it's very important for us to learn those theorems. So don't forget to share this lesson, like and comment. Now let's move on to question B. In question B, we are given a diameter as well, this center O. So the angle formed by this diameter here is this I and J. Let's label this as well, A, B, C, and D. So I want to find the value of I and J. But looking at this, I have my 65 degree here. You know, the combination of I and J from this line AB to the diameter. So this line has formed one angle on this circumference. This line, which is this diameter, has divided this circle into two equal parts. When it divides the circle into two equal parts, we call it a semicircle. And the angle, that line, angle formed by that semicircle will equal to 90 degrees. You know, the whole circle is 180. So half of 180 is 90. That's what they call it semicircle. Now, this angle C here equals to I plus J equals to what? 90 degree. Reason, angle in a semicircle. Now, but I don't have the value of I don't have the value of J. It's not possible for us to be looking for two values, two things. So in this case, when we look at this one again, okay, let me consider this line CB. If I consider this line CB, this point here is my minor segment. Minor segment. While the remaining part, they are my major segment. So in this case, my angle I and angle 65, they are in the same major segment. So in this case, I is equal to 65 degree. Reason, angle in the same segment. I've gotten my I, so it's very easy for me to get my J now. So I will now say I plus J, my I is 65 plus J equals to 90 degree. J equals to 90 degree minus 65 degree. My J equals to 25 degree. So this is how to go about this theorem 3 and theorem 4. Don't forget to subscribe if you are a new member on this channel and also click the notification bell in order for you to get our subsequent classes. I will see you in the next class when we'll be discussing more examples on the theorem 1, 2, 3, and 4. Thank you very much.